Now let's look at some problems that involve more than one step. And what I have here are sort of my rules that I like to follow when solving equations. We'll see a bunch of different types. So the first thing I like to do is I like to simplify, which means like anything you possibly can do. So I like to distribute parentheses first, if I have parentheses. If I have fractions or decimals, I usually like to clear those out. So we'll look at some of those later on. And then I do combine like terms on each side of the equation. So basically, if you see something that's easy to do to clean up that problem and make it easier, that's what you're going to do first. Once you've cleaned it up as much as you possibly can, then we're going to start collecting like terms. So we're going to bring all terms with variables to one side of the equation and all terms without variables to the other side of the equation. And we do this by adding and subtracting. So this is when you're adding and subtracting to both sides of the equation. After that, you're going to divide. So you divide both sides by whatever's being multiplied with the variable. And then finally, you can always check by plugging your answer back to the original problem. So let's look at this first one here. And if you need to, follow up to the steps. So first, do I have any parentheses? Do I have any fractions or decimals? No, so I don't have to worry about that. And then I look on each side of the equation. Okay. Is there anything I can do? So I have a 2x plus 3. Can I put those together? No, I can't. They're not like terms. Here I just have a 17. So there's nothing for me to simplify right away. It's just kind of, everything is just hanging out. Nothing can be combined together. So now I'm going to start moving things around. We want to get our like terms together. And of course, I want to get the x by itself. That's the goal. So if I'm getting the x by itself, I really want to get this plus 3 away from it to the other side. And that 3 also wants to go with the 17 because they're like terms. They want to be together. So to cancel it from one side to the other, use that opposite idea like we did in the first couple of easier examples. To move it from one side to the other, if it's a plus 3 here, I'm going to use a minus 3. And that allows me to bring it to the other side. So plus 3 and minus 3 cancel. And then I'm left with just 2x equals, in this case, 14. Now all my like terms are combined, right? I have my x's here, my numbers here. This is what I want. I want my x's on one side and my numbers on the other. I'm trying to get x by itself. But I still have something hanging around. I still have this 2 hanging around that I want to get rid of. So now we're in the dividing step, right? 2 is being multiplied. So the way to cancel it out is to divide it out on both sides. So finally, x equals 7 is my answer. And the last thing you can do is to check. So I go back always to the original problem to check my answer. I'm going to replace the x with 7. 2 times 7 is 14. And 14 plus 3 really is 17. So this is good. My answer checks out. All right, for the next one. Now, I do see parentheses here. So before I start moving anything around, clear out those parentheses. So I'm going to use my distributive property. And I end up with 2 times x is 2x. And 2 times minus 4 is going to give me a minus 8. I'm just going to bring this minus 5x down equals negative 5. So again, I'm just trying to stay nice and lined up here and not change the order of anything. Now my parentheses are gone. I don't have any fractions or decimals to worry about, but I do want to look on each side first and see if I can add or subtract anything. And I do see on my left side of the equation, right? I like to draw that line so I can see my two sides. On my left side, I see a 2x and a negative 5x. Those are like terms, so those can go ahead and be combined together. 2 minus 5x is negative 3x. So this becomes negative 3x minus 8 equals negative 5. So that is my simplifying step here. Now I have more like terms that I want to get together, but they're on different sides of the equation. That's okay, I can fix it. So I want the x by itself. If my x is already on the left, leave it there and bring that 8 to the right. So if it's a negative here, I'm going to make it a positive 8 because that will allow me to cancel it on the left and move it to the right. So I have a negative 3x equals 3. Now all my like terms are combined. So this is good. You want to make sure that you have no more like terms hanging around because we want to make sure we get them together. And again, I still want that x by itself, so I have to get rid of this -3. That -3 is being multiplied, so the opposite of that is division. And finally, I get x equals -1 as my solution. All right. Now, for this one, I'm going to let you guys do the checks for the rest of them, just to save a little bit of time, but we can just take that number and plug it right back in and make sure we get a true statement. So you should see that you get -5 equals -5 once you simplify. All right, and let's do another one. So here I don't have any parentheses. I do see on my left side and my right side, I don't have anything I can really even do, right? 5x and 12 are different, 8x and 24 are different. They're not like terms, so I cannot combine them. So I have to start moving things around. I do want my like terms together, they're just on the wrong sides. So notice I have x's on both sides this time, and I have numbers on both sides this time. So you can kind of choose which way you want to bring them. I will say that most students probably like to bring their variables to the left, so I'm going to stick with that. So if I want to bring my variables together on the left, this is a positive 8x. I'm going to use a minus 8x or a negative 8x to make that happen. So it's going to cancel it from the right and bring it to the left. 5 minus 8 is -3. So my x's are together, but my numbers aren't together yet. So now I'm going to go ahead and do that. If my x's are on the left, you want your numbers to go to the right. So we're trying to get that x by itself. So we're separating everything. So I'm going to bring this guy over here. And if it's a negative, it's going to become a positive. And again, I'm using those words negative and subtraction interchangeably because they really basically mean the same thing. So you could say -12, +12. You could say -12, adding 12. It's the same idea. And 24 plus 12 is 36. Now everything is combined and collected. My like terms are collected together. So my final step is going to be division here. I'm going to divide out that -3 on both sides. And I get x equals -12. And again, you can go ahead and plug that in to check it. And you should get -72 equals -72 if you're doing this out at home. So you're just plugging in -12 to both x's, simplifying and making sure you get a true statement on both sides. All right, so our last two here are going to be on fractions. So when you have fractions, you can work with them if you want to. So there's nothing wrong with working with fractions. They're just kind of a pain because you're constantly thinking about common denominators and reciprocals and that sort of stuff. So what we usually like to do is clear them out if we can. Now, first of all, I'll say I have no parentheses. If I had parentheses, I still like to do that first. I think that's the easiest thing to do. But if I have fractions, I'm going to clear it out. And we can clear or cancel fractions by multiplying everything by a that looks terrible, by a common denominator. Okay. Any common denominator is fine. Usually we try to do the least common denominator because it'll make your numbers easier to work with. But any common denominator is fine. So my two denominators here are 2 and 5. So I want to use a common denominator for that, and that would be 10, right? So our common denominator here would be 10. So I'm going to multiply every single part by 10. The reason I have to do everything by 10 is because technically using that, that equality rule, we can multiply both sides as long as it's the same way. So technically I'm multiplying both sides by 10. And what's going to happen is when I multiply this side by 10, it's going to end up distributing to both terms. So an easy way to think of it is to just multiply every single thing by 10 and it'll keep it balanced. But it works because of that equality rule. So we're multiplying both sides by 10 equally, and then we're applying distributive properties to multiply that through. So what you're going to end up doing is this. Again, I'm just going to multiply each part by 10. Now I know the 4 does not have a fraction, but it still has to get multiplied to keep everything balanced. And then I'm going to go ahead and start simplifying. Now, if I've done this correctly, my fractions should cancel. So here, 10 divided by 2 is 5. And 10 divided by 5 is 2. Once I cancel out, I'm going to multiply whatever's left over. 5 times 3 is 15. So this becomes 15x equals 2 times 8 is 16. So 16x minus, now there was nothing to cancel here, so it's just 10 times 4 is 40. And now you're going to see you have a regular example that hopefully you know how to work with, right? So here, I don't have anything to really clean up. I do have like terms, the 15x and the 16x, but they're on different sides. So what I'm going to do is move things around. I only have the number 40 and it's already on the right. So I'm going to move my variables to the left so that, again, I have variables on one side, numbers on the other. We want to separate those different things out. If it's a positive 16, I use a negative or a minus 16. And then I have negative 1x is equal to negative 40. Watch your signs. That's going to be a negative 40. And finally, divide by negative 1. And we have x equals 40. Okay. And one more here. So my two denominators are 3 and 2. So my common denominator would be 6 here. I'm going to multiply every single part by 6. So I have 6. Now here we only have 2 fractions. Sometimes you may have 3 fractions, that's fine. If you have more than 2 denominators, you're just going to find the common denominator of everything. So if the 7 had a denominator of 5 as well, then I would just find the common denominator for 3, 5, and 2 instead, right? So you just do whatever the common denominator is for everything. So you can cancel it all at once. So here, 6 divided by 3 is 2, and 6 divided by 2 is 3. I multiply with what's left over. 2 times 2 is 4, so I have 4x. 6 times 7 is 42, minus, and 3 times x is 3x. Now again, I do want to combine those like terms. They're just on different sides. And I want to get my x's on one side and my numbers on the other. So I'm going to, again, bring my x's to the left here because my 42 is just hanging out on the right already. Minus becomes plus, and I have 7x is equal to 42. Finally, divide both sides by 7, and x is equal to 6. Now, I'll do one more check here, just so you can see it with fractions, but it works the same way. We just go back to the original problem, and I plug in my answer for the x. 2 times 6 is 12, so I have 12 over 3 is equal to 7 minus 6 over 3. 12 over 3 is 4, and 6 over 3 is going to give me 2. Oh, wait, did I make a mistake here? So now look, now I'm checking myself, and I'm saying, perhaps I made a mistake here, or I think I made a mistake in my check. Oh, I did, see? Sometimes, and this happens to me too, you make a mistake on your check because I wasn't paying attention. But notice how my equation was supposed to have a 2 here, and I wrote a 3 by accident. So if you find that your check is not working, and students do this a lot too, so I do it as well, is double check your check first. Make sure you didn't make a mistake in your check before you go erase everything, right? But if you're sure about your work here, then you must have made a mistake here if it's not checking out. So 6 divided by 2 is 3, and then I do get 4 equals 4, so this works.